Hello and welcome back. In response to a few questions that have come up in the comments on the previous videos, I'm actually going to talk a little bit this time about what the condition of the parts of the engine were like before I cleaned them up, talk about some of the cleaning processes involved, and we're going to actually take apart the starter motor and one of the magnetos, which I haven't touched yet, and it'll be really interesting to see what they're like inside, what I need to do to them to get them working again, and I'm totally confident that both of these things will go again. Okay, so this is a standard BTH starter motor that you find on a Merlin. It's got a splined output shaft. It doesn't turn at the moment, so not surprisingly it's had water sitting in it. This is all nickel plated, so it's quite nice. It hasn't really been attacked. I mean, the screws on the top of the brush cover, one of them's still nickel plated, the others are corroded. This is what happens in a sort of peat bog type of environment. So the aluminium, which is this casing down here, tends to survive very well. Nickel plating's generally alright as well. Bare steel components or components that aren't plated very well tend to corrode. So we'll start with taking the brush cover off with this screw here. Actually, look in there. Here's some of the peat. There was quite a lot of this stuff actually in various crevices all over the engine, and I've got a box about 2 cubic feet, I suppose, of peat out of the various bits and pieces on the outside of the engine and chucked it in the garden. So, twist that around. Just because I'm right-handed. So this is a stainless steel screw actually, which is quite nice. I'll whip that off there. The first thing I need to do before I can take anything apart on the spindle or the shaft of the starter motor is to take the brushes out, because they're spring loaded up against the commutator inside. So there's the brush cover. It's got this felt type, well, it's cork actually, it's a cork gasket material behind it. Whip that off. Sticking somewhere. This could end up quite heavily edited because it takes quite a long time to get these things apart for obvious reasons. So there's one of the brushes. We can already see it's a bit clagged up inside, but actually, I mean, it doesn't look too bad. So to get these brushes out, they're spring loaded. You push them in, you rotate them. You can see I'm going to need a pair of pliers for this anyway. There we go. So there's the spring. The brush is still in there because it's attached by these wires. So we're just taking the brush retaining springs out. There's another one. There's a broken spring straight away. That's interesting because I thought these were stainless steel, but possibly not. They're certainly not rusty anyway. Because this engine spent most of its time upside down, in fact nearly all the time, until I got it, this will have been up on the top, so I'm hoping it hasn't actually had water sitting in it after it was recovered, but it will have done when it was in the ground. So there's a bit of a bash on the corner of it there, but that's okay. We'll whip this screw out the top. It's got a lovely electrical smell inside it as well, even after 83 years, I think, something like that. Right, so these water pump pliers, these are quite worn actually, but pliers like this, if you get a good pair, they're really useful for getting hold of stuff like this, because these are dome headed screws. So again, nickel plated cover. To be fair, that's quite heavy actually for an aircraft part really. That's just purely a guard. There's been a little bit of water sitting in there. But first of all, I'm going to take these screws out. Again, these are either stainless steel or nickel plated. I suspect they're nickel plated. And that goes down into the motor winding, so I'm going to take that screw out. And there'll be another one on that side now. And then before I go any further with it, I'm going to mark it up, because up till this point it hasn't mattered what the orientation of anything is in it, but it does now. Now, there we go, so that's the top off it. So it doesn't look too bad in there. Yeah, as I thought. Oh, there you go, look, that brush moves, you see, in there. And then the brush spring pushes down on it and puts a light pressure onto this commutator. So that one's moving. That one doesn't appear to want to move. That one moves, and that one moves. Right, this is one. Can I get that one to move then? Yeah, there we go, they're all moving, so that's good. So there isn't too much in there. There's the outer race in the top of there of this ball bearing. And there you go, look, the ball bearing turns, so that's all happy days. We can clean that up. Now, clearly it's been a bit, there's definitely been water in there. So one of the things I'll do is put a meter across this and take some measurements of the windings. There we go, that's the last one. That's a little bit corroded. The rest of them are okay. There we go. So I'm able to remove that. There's obviously been a lot of water sitting in here. You can see in the top of there. And again, there's the outer race. So these are effectively angular contact bearings. So rather than the whole inner and outer race like on a conventional ball bearing coming off all together. And again, they're turning okay, even though they've been in the water. The inner race and the balls are on there in a cage, and then the outer race is basically more one-sided, so the balls can push into it, but they won't be able to push down out to the other end. So now there's all sorts of crap falling out of here, isn't there? Take this shaft out. Armature, as they call it, sorry. Right, it's obviously been full of water in there. And one of the important things with these is to make sure that if you're going to power it up again, that it is actually dry. I strongly suspect this is, but it's probably going to be worth putting it in a heated environment at some point just to make sure that is the case. So I'm going to clean this up initially. You've got to be very careful because there's wire around the outside of here, and this is put there to keep the actual copper windings, which of course are fairly heavy, to keep them in place as the motor speeds up, particularly if you keep your finger on the starter button when the engine's running, once it's up and running, which you do to a certain extent. This thing will speed up to its maximum RPM offload, and there's quite a bit of force on these windings pushing them outwards, so these wires are there to keep them in place. So all in all, cleaning this is something I'm just going to have to do very carefully. So let's just have a measure of some of these motor windings. I'm using special low resistance meter. It uses 2 pairs of wires to do the measuring, and provided I clip both of these terminals onto each of the connectors, the resistance of these wires is cancelled out, and it can measure down to about something like 0.001 of an ohm. These are very low resistance windings, by the way. So I'm going to just slacken that nut off there so I can get across that terminal there. And we'll see what sort of readings we're getting from there to there and from there to there. Okay, 0.014 of an ohm, right. And that's stable, if you can see that. That's stable, right. So what's going on here then? Let's have a look. .014 of an ohm. Happy days, they're both the same. There we go, right. Possibly 0.028 across both of them, not sure about that. There you go, 0.028, right. So actually those windings are probably okay. So for the initial cleaning, I'm going to use a motor powered wire brush, which I'll show you. But I can't use that too much on this because a lot of these parts on here are quite fragile. So. But it's the most useful tool for steel. But also, another thing is, this is very clean because it's nickel plated. So actually this will be extremely easy to clean, and I'll show you how to do it. So if I literally just get a cloth with brake cleaner on it, That's how it comes up. It's got some kind of watermarks or something on it. So another way of doing that is white spirit, something like that. Petrol probably. Petrol wouldn't take the paint off. That will clean that. You can see that actually, apart from these rusty screws which are holding these pole pieces inside here, this is pretty much what this would have looked like when it was new. Another useful cleaner is Scotch-Brite like this, and it comes in different grades as well. You can get finer grades in this green stuff. And it's okay on this nickel plating. It works on aluminium very well as well. But I'm not actually rubbing very hard on this. There, there's a bit of the shine back on it. So this is a rotary wire brush. It's actually an approved way of cleaning various bits and pieces, even in the engine manual. This is a nickel plated screw off the starter motor. It's okay to do these with it, but you don't want to push really hard on it because the plating can come off. You have to be gentle. This is actually a brass bristle brush as well. What you can't do is start cleaning these aluminium components with it, because some of you may have been around museums where things have been cleaned with a wire brush and you've got all these really deep gouge marks all over the aluminium. It's really bright and shiny, but it looks absolutely awful because it never looked like that in the first place. You can see it's got a machined finish on it, or it's got a bare cast finish on it, and you can clean this and you can paint strip it, which we will, but definitely don't start attacking aluminium with a wire brush, whether it's a brass one or a steel one. If it's a brass one, if you're going very, very lightly, if there's a good reason to do it, like to remove some kind of staining, then yeah, but otherwise definitely don't. But for any steel components, or some, or quite a lot of plated components, absolutely brilliant tool. So I'll show you. Now this commutator, not the commutator, sorry, now this rotor, and you'll see there's quite a lot of rust on there. I'm not going to touch that, and I'm not going to touch that, but I'm just going to get some of this off here, and some of that. So you can see that's got that quite nice and clean. There's some corrosion pitting, particularly in there. If that end of the thing is washed in petrol, for example, then you can get all the grease out of there, re-grease it, and it can go back together. We need to clean this, which we can use the Scotch-Brite for again. If you're using these wire brush machines, these gloves are okay to wear, but any other type of gloves, don't wear anything stronger than these on any kind of rotating machinery, because they won't necessarily break if it snatches, and obviously wear goggles with it as well. Okay, so that's everything cleaned up and ready to assemble. I've had this in the lathe and used 1500 grit wet and dry paper on the commutator there. Bearings just need re-greasing now. Paint stripper on these two aluminium castings. And another thing about the paint stripper is it also takes off the remains of the gasket as well. And it's quite a good degreaser and decarboniser, so you can use it for various other things. Same in here. Just use WD-40 to free up the brushes. They're perfectly okay now, so everything looks alright in there. All I've done inside here is just sanded inside these pole shoes, because actually looking at the state of the bearings, I'm thinking that the reason the starter wouldn't turn by hand was probably corrosion between here and this rotor, because there's very little clearance between them. Had to borrow a replacement spring from another starter motor. I'm going to have to try and find some of these. I think I might have one actually somewhere, but in order to get this up and running, done that. So we're just about ready to put it together. Okay, here goes. I'm fairly confident because everything measured up right on it, but you never know till you test it. Lovely. Alright, it's not a load test, but pretty confident that'll work alright. So there you go, that's the starter. It took about 3 hours of work in total, not videoing, to do this. It was in particularly good. Not lucky. I mean, one of our customers years ago actually had one of these things rewound, and that was very difficult because not many companies really touch stuff like this these days. Just going back to the paint stripper I was talking about earlier on, I'm really referring to professional paint strippers which contain dichloromethane, and they're very much restricted on sale. You have to wear breathing apparatus when you're using them, and in a well ventilated area, that type of thing. They're really the types of paint stripper that will decarbonise and that type of thing, but very extremely useful, and for museums and organisations like that in particular could be quite useful. The brief on this engine as well is that I just basically want to get it running. I need everything to be functioning properly. If this was going back in the air, every single component would have to be stripped down from it and inspected, NDT'd, which is non-destructive testing, where you check for cracks and that type of thing, particularly on steel rotating components. So there's a huge difference between what I'm doing here and what I would have to do if this was actually going to go back on an aircraft. So let's have a look at this Magneto. I'm dying to see what's inside here. I mean, it could be brilliant or it could be really terrible, so let's have a look at it. Okay, so I'm going to start with this. The easiest thing to look at in here is going to be the points. So there's a spring-loaded bar running across it, and I can just unscrew that. The points carrier is connected through into the Magneto by that sliding terminal. That's the cam which operates the points, and the points are inside here. I can almost guarantee the spring on the points is going to have corroded and failed, but let's have a look. There we go, right. Not sure what that is. Okay, so actually there are the points. So they do actually still open and close, so in theory the engine could still run. Apart from cleaning the points, this part of the Magneto would actually work still. The next piece we want to look at is inside this distributor. So there are two screws down here, but the other two screws holding it on are actually behind the distributor block in there, so we have to remove this first, which is these two screws in the top of here. Biggest problem with these things tends to be that they can expand when they get damp, and that could cause a problem with actually getting it out of here, and they break very easily, being Bakelite as well. So just going to have to see what happens here. That's the screening plate that's over the top of it. Electrical screening. Put that over there. So now in theory this thing isn't... Oh, it's loose. Wow, brilliant. I was going to say isn't attached. Right, okay. There we go. Well, that's a relief. There's two steel bearing plates that sit on top of it there. It's quite rusty. I mean, it's definitely been water inside here. Look at that. Wow. Okay, so the distributor terminals are on the inside of here. The grey stuff that's all flaking off the inside of this is a lacquer, an insulating lacquer that was put on it. It doesn't appear to be broken, so that's good. Right, so that's the two internal countersunk screws removed. Just removing the last of the outside ones. And we should be able to get this off. There we go. Right. Be careful not to damage that rotor. So it doesn't look too bad in there. And there's a better view of the rotor assembly. I'll explain how all this works later on when it's going back together. We can now access the cover for the actual coil itself. Right, so I've had to break the insulator for the booster coil connection because it's expanded in there, and don't know what all that stuff is. Basically, this material is expanded inside here, and I'm going to have to be very careful taking that out because I don't want to damage this component. This can be sacrificed, and this is quite often the case when you're working on things like this. If you drill a fastener out, for example, it's better to do that very carefully, or on a milling machine very accurately, than it is to damage the casting itself. So there's the coil, there's the condenser sitting on top of it, and this is the booster coil connection, which would look like that, because you can go in from either side of it depending on which side of the engine the magneto is on. So I'm going to have to find a way of getting the rest of that out. And the next part I'm going to remove is this base plate for the points. Yeah, quite heavy that for an aircraft part, made of bronze. Now I'll tip some more of this dried off lacquer out of here. Look at that. I'm sure some of that stuff coming out of there are parts that we need, but anyway, parts that we need. So there's the sliding points, contact onto the points assembly, and the wire going through into the coil. You can see the steel gear. The gear on the edge of here is Tufnol, by the way. This is Bakelite, the insulating material. It's got a Tufnol gear on it, and that can certainly expand with damp, so that's part of the reason why this thing's tight. You can also see where there's been water inside here. There's corrosion on those teeth on the steel gear. That'll clean up. And I suspect the main reason why I can't turn it will be the same as the starter motor. So there's a generator inside here and a permanent magnet system. It's probably corroded, and the two things are probably touching, and they've virtually corroded together, so that's all going to have to come apart and be cleaned. Okay, so before we can access the coil itself, we need to remove this component here where the booster coil feeds in. To do that, we need to remove the rotor. We'll take the main armature out of the magneto as well. So the rotor's held on by this serrated nut here. I've taken some of the screws out already. We'll put the last one out of there. So then that steel plate comes off. That enables us to get this tool on to unscrew this. Retaining nut, which is that. Now this should, if it's not corroded, this should lift off. Let's have a look. I'll tell you what I'm going to do. I'm going to take this out first. So I've taken the screws out of the front end of here, and this whole assembly, the whole armature just taps out. Like that. And this is a rotating magneto, so this is a magnet here. Some of the more old-fashioned types have a big like horseshoe magnet over here, which is a rotating coil, where the coil will be wound on here like an electric motor. So that's the difference between this and certain other types of magnetos. There's a bore race in there, another one on this end here, which sits in obviously a race that's inside this housing. There's your timing gear, and there's the cam. Definitely some corrosion on here, particularly on the gear. You can see there's a chunk missing off it there, so I'm going to have to clean this gear up. Some very bad damage to the teeth there, so it's conceivable that might have to be replaced. There we go, front bearing, rear bearing, and this is the conductive ring that the booster coil connection actually makes onto there. And that piece comes out like that. Now I should be able to unscrew these 4 corner nuts and remove the coil assembly. Okay, so there's the points wire. There's the wire that goes to the other side of the condenser. I'll remove the condenser. Okay. And now we need to remove these elongated nuts which are holding the coil in position. So now we remove the two clamp plates that are on top of the coil. Notice how they've got a cutout in there to miss that cable when they're coming off. Now the coil should be free. Just being really careful because there's a terminal that takes the HT output from it and I don't want to break it. There. Goes into the centre of there, passes through the middle of this component which we're going to take out now and comes out at the end of there into the rotor. There we go. That's that component there which holds this Bakelite conductor in place. There. I might again actually leave this in because I'd have to take the terminal off one end or the other, but then I might need to replace the cable anyway, so if I do decide to change the cable then I'll take it off. That's as far as we need to strip it at the moment. So the next interesting thing I'm going to do before I clean some of these parts up is to measure the coil, see if it still conducts. So we go across the primary and we've got about 1 ohm, which is bang on. Yeah, definitely looks right. Now the secondary, we'll have to change the range because it's probably about 5 to 10,000 ohms, something like that. So I'll just connect to one of the primary windings. It doesn't matter obviously which one because it's connected through there. So, oh, there you go, 5. So 5.05 kilo ohms. So I've paint stripped half of this outer casing. That's how it looked like before. And this is a better example of aluminium because you can see it's a bit patchy, and this is what tends to happen when the paint flakes off in places, which would be the darker bit, and the brighter parts of the bits where the paint was still on them. So one way you can clean that up is just using Scotch Brite, which I'll have a go at now. You can also use emery tape, just fairly fine. And that's got rid of most of these marks on here now. So I've cleaned up this rotor and the teeth aren't too bad. There's a chunk missing out of there and there. I think I'm going to put this back in and try it. It looks as though it'll still drive the gear. And in the interest of keeping everything in this engine, I think that's the way to go with it. Some really bad pitting on the shaft there. I'm sure this has just been full of water, possibly since it came out of the ground. And the Bakelite components like this rotor arm, I've just cleaned up using paper towel. Try and avoid using anything like brake cleaner because it can affect the makeup of the materials themselves. Don't use anything that puts scratches on it either because high tension electricity, if there's a scratch down here, it'll tend to make it track down to ground. So again, that can ruin these things. They need to have a fairly decent finish on them, but actually they end up fairly easily. Bronze materials like this points, back plate, that's been wire brushed. Need to clean inside there. You can go in there with brake cleaner because that's a bit oily, what's in there. And that's almost the kind of finish it would have had when it was new. You can use Scotch Brite on it and shine it up a little bit. But I think I'm going to clean everything up on here, put it back together, just see if it works. And here we have the finished Magneto ready to test. Turns okay. There's the adjustable timing moving all nicely. Everything's gone back in the Magneto. These are the two cables. There's the booster coil cable with a broken end on it. That's the Magneto switch lead, which came out of the bottom. And the only other things which haven't gone into it are just a load of more heavily corroded screws, some of which I've had to put a drill in to get them out, so I've changed some of them. Other than that, all the wiring inside is actually the same. I haven't changed any of that. So this is a variable speed motor, and it can be used for testing magnetos like this, or generators or other accessories. And this assembly is a set of spark gaps which I use to just quickly test if a magneto is working or not. You should never run any ignition system totally open circuit. It should always drive into some kind of spark gap, because if you don't, invariably it is going to find somewhere else to go, and then that usually starts a carbon track running somewhere inside the unit, and it'll just not work properly afterwards. Hey, there we go. Excellent. Let's just speed it up a bit. Oh yeah, brilliant. Well, there you have it. That couldn't have gone any better, to be honest. Isn't it amazing how you can have something sitting for 80 years underground with water in it and it all goes back together and works? Just amazing engineering. I wouldn't want to put it back in a plane though, as it is. It's a bit rattly, which is to do with the corrosion on the steel gear, and it's actually putting backlash into the teeth, and the magnetism being generated now is causing it to kick backwards and forwards as it goes past that point. So that would ultimately damage the Tofnol gear with the distributor on it if you ran it for a long period of time. I'm probably going to repair that gear actually by TIG welding it and remachining the teeth out. Other than that, this would definitely run on that engine and I'm really happy with it. Just a couple of other processes for cleaning the aluminium which I haven't really touched on. I used to use soda blasting myself, which is a non-abrasive cleaning process which removes the paint and it removes a lot of the dirt and some of the corrosion from the aluminium, but it doesn't really take off the dark patches, and you would still have to use something like Scotch-Brite for that. You also have to have somewhere to do it because it creates a lot of dust. It's not the kind of thing you can do at home really. Another process which uses some degree of abrasion is vapor blasting, which is effectively blasting with water with a very small amount of abrasive. That gives a lovely clean finish all over it, which is very smooth. It's still not the original finish though, and again if you go on from that to proper abrasive blasting with various different types of media, which is quite a common thing, I wouldn't recommend doing anything like that on these type of castings unless it's something that's definitely going to be painted, in which case it helps because it does help the paint to adhere, but it completely changes the finish of the material. So I hope you enjoyed that. I'm going to explain the ignition system in a bit more detail in a later video when I assemble it all to go onto the engine. And this Magneto and the other one will also need to be tested effectively under load, which means with the spark plugs under an air pressure of about 100 psi, which simulates the engine compression, because it's much more difficult for it to spark under pressure. If it passes that test, then I'm going to run this on the engine. And finally, last weekend I had a surprise visit from a good friend of mine, Bill Smith from the Bluebird Project. Now he's been down to Birmingham to meet Barry Hares, who built a 1/5 scale running Merlin engine many years ago. And we were looking at full size parts of the engine to illustrate just how much work goes into making something like that. Now I've put a link to that video in the description of this one. And please follow Bill's channel, have a look at what he's got on there because it's absolutely amazing. So I hope you enjoyed this video, and until next time, if you haven't subscribed already, please do so, and you can follow the rebuild of this fantastic engine that I'm putting together here, and possibly other engine related stuff I get up to in between. Thank you.